In this question, we need to provide the reasons for given statements. The first one is nitrogen dioxide dimerizes readily. They will dimerize to produce dinitrogen tetroxide or N2O4 because the odd number of electrons and the instability of the monomer NO2 will produce this dimer. NO2 has an unpaired electron and making it a reactive radical. To achieve a more stable electronic configuration, two NO2 molecules combines to pair up these electrons and they will produce N2O4. The dimerization reduces the total energy of the system while NO2 is paramagnetic and unstable molecule whereas N2O4 is more stable and diamagnetic in nature. The second statement is the chlorine acts as a bleaching agent. Chlorine can act as a bleaching agent due to its strong oxidizing property. It removes color from the substance through oxidation and break down the chromophore into colorless products. Chlorine is commonly used in household bleach and industrial bleaching processes. The third statement is, in spite of small size, electron gain enthalpy of oxygen is less negative as compared to sulfur. The electron gain enthalpy of oxygen is less negative compared to sulfur because of the small size of oxygen atom. In oxygen, the added electron experiences significant electron-electron repulsion and it makes it less energetically favorable to accept an extra electron. In contrast, sulfur has a larger atomic size and more diffuse 3p orbitals. So the electron-electron repulsion is lower in case of sulfur and it will let them to accept an additional electron more easily and results a more negative electron gain enthalpy. The next one is, unlike chlorine, fluorine forms only one oxo acid, that is HOF. This is due to the chemical properties and high electronegativity of fluorine. Fluorine is the most electronegative element, which means it strongly attracts the electrons. This makes it difficult for fluorine to form the multiple bonds with oxygen or other elements because the high electron density would make the compound highly reactive and unstable. The next one is the presence of strong bonding. The bond between fluorine and oxygen in HOF is quite strong, however forming additional oxo acids with fluorine like those seen in other halogens. The next one is stability. The higher oxidation states of fluorine are not stable. For example, in compounds where fluorine would be in higher oxidation state, the resulting species would be highly reactive and would decompose, making stable oxo acids difficult to form. The next one is noble gases have very low boiling points. The boiling point depends on the intermolecular interaction exists between the individual molecules. In case of noble gases, we could see the type of intermolecular interaction is van der Waals forces. But in case of these halogens, the van der Waals forces is comparatively weak. It means the boiling point will be low. Now let's come to the OR question. We need to draw the structure and name the shape of the given compounds. The first one is SF4 or sulfur tetrafluoride. Sulfur tetrafluoride has a seesaw geometry. Here sulfur contains one lone pair of electron and four bond pairs of electrons. The second one is ICl3 which has a T shape. Here iodine contains two lone pairs and three bond pairs. In the next question, we need to provide what will happen when chlorine gas is passing through hot and concentrated sodium hydroxide solution. When chlorine is passing through concentrated sodium hydroxide solution, a disproportionation reaction will take place. In this reaction, chlorine is simultaneously oxidized and reduced. The products formed are sodium chloride, sodium chlorate and water. The second one is xenon hexafluoride is subjected to complete hydrolysis. When they undergo complete hydrolysis, it reacts with water to produce xenon trioxide, xenon tetrafluoride and fluorine gas. But the reaction can be complex. Now, the last one is when concentrated sulfuric acid is poured into cane sugar. When concentrated sulfuric acid is adding, the dehydration reaction will take place. It means it will absorb or removes the water from cane sugar and they will produce the carbon and sulfur dioxide along with water.